Number 6, we've got an indefinite integral. This is not in our list of integral formulas that we know. So we look for substitution. Well, there's an exponential involved, and we're looking for an inside function, and where the inside function is on an exponential function is up here in the exponent. So I'm going to try that because that's an inside function. And what's going to happen is du is going to be 1 over 2 square root of x dx. So this becomes e to the u, and then I still have my square root of x in the denominator dx. Well, that's 1 over square root of x. And so from here I can see that 2 du equals 1 over square root of x dx. So that will replace this stuff that's left over. So doing that, I'll get 2 du. So I'll put 2 du is going to replace what was left over. And you can do that as long as it's only a constant. If there was a variable that I would need, then I'd have to go try to solve for that or something. Okay, so anyway, integrating this now, that's really easy. That's just e to the u. And putting my u back in this last step, it's 2e to the square root of x. And now I've got a definite integral. And here this is not in my list. Don't split this thing up. You can't split up the denominator like that. If it was the numerator, I can split up a numerator, but not a denominator. So I'm stuck with that. I don't see an inside function, but my other substitution I look for is I look at the denominator. And so sometimes substituting for that, I can see what my differential is going to require here. When I take the derivative, remember, derivative of 2 to the x is 2 to the x, but you got to remember there's a natural log of 2 that goes in front of that. And so you can see this becomes u in the bottom. I would still have a 2 to the x dx left over. There it is. And so 1 over natural log of 2 du will replace what's left over here. Now, it's a definite integral. We'll fix that in a minute. So what this is going to turn into is 1 over natural log of 2 du is going to take out that 2 to the x dx. So that's gone. So natural log of 1 over natural log of 2. And what I have left then is just a 1 over u du. So 2 to the x dx went away. 1 over natural log of 2 du went in. Now my limits of integration, I can figure those out by plugging in. So my lower limit, when I put in 0, that's 2 to the 0, that's 1 plus 1. So that's going to be u equal 2. And when I put in the 1, that's 2 plus 1, that's going to be 3. So from 2 to 3. Now everything's in terms of u, and so I don't have to convert back or anything. So to finish this up, I know that I'm going to get 1 over natural log of 2. This is natural log of the absolute value of u, evaluated from u equal 2 to u equal 3. And so I get 1 over natural log of 2. Plugging in, I get natural log absolute value 3 minus natural log absolute value 2. Well, you can see the absolute value is unnecessary in this particular problem because absolute value 3 is 3. So I get 1 over natural log of 2. And then this is going to be natural log. Remember, when you have a difference like that, you can write it as a quotient on the inside. And that's pretty much it. Natural log 3 halves over natural log 2. Not much I can do with this. I'm going to leave it like that.